know why this issue's been so uncomfortable. Okay, domain, here we go, number 1. This is a two-parter, right? What's the denominator tell me? X can't be -2. And the numerator says 5 minus 3x has to be bigger than or equal to 0. I cannot do this in my head, so I'm writing it down. That means this, which means this. X can't be -2. X has to be less than or equal to 5/3. Because 5 minus 3x has to be greater than or equal to 0. So in the answer blank, I have to write both of these things this time. Right? I got some function f of 4 is -2, and f of -4 is -2. Does that describe an even, an odd, or a neither relationship? Even. This is even. What does even mean? Change the sign on input does not affect output. That's even. If you're confused by that, plot those 2 points. 4, -2, -4, -2. What are those 2 points symmetric about? The y-axis, which means it's even. What if the problem would have been f of 4 is -2, f of -4 is +2? That would be odd. Because what does odd mean? Change the sign on input changes the sign on output. Again, do not be confused, just plot the points. What are those symmetric about? The origin. Bailey?
How do you get neither?
If neither one of those 2 things happen. So obviously if this worked out to be some other number, then it would definitely be neither, right? All right, number 3. All right, so we're just subtracting in the beginning, so this is easy. What's that equal? B of x minus a of x. X squared plus 1 minus 2x minus 3. So x squared plus 1 minus 2x plus 3, x squared minus 2x plus 4. Does that look okay to everybody? And the next one says a of 1 plus b of -2. Okay, what's a of 1? -1. What's b of -2? 5. So the answer would just be 4. We're adding those together. This is composition. So what do we do first? Find a of 2. So what's a of 2? So this is 1. This right here is 1. So aren't we just finding b of 1? And that would be 2. And a of b of x. So what's b of x? X squared plus 1. So this is x squared plus 1. So I'm finding a of x squared plus 1, which would be what? 2 x squared plus 1 minus 3. which is 2x squared plus 2 minus 3, or 2x squared minus 1. Okay, number 4. Q of P. I need Q of P of x to be 8x squared plus 5. So I have to find Q and P that make this happen. All right, well, what has to happen? What does this function have to accomplish? 3 things. What has to be accomplished? Got to square, got to times by 8, add 5. Got to have those 3 things happen in that order. So the way this is set up, which function is first? P. So you got to make a choice. You got 3 things to get done, and you only have 2 functions to do it. So somebody's going to have to do 2 things. Doesn't matter with who. If we say, all right, we're going to let P do 2 things, then what are the 2 things P has to do? Has to multiply, or has to square and multiply by 8. So that would be 8x squared. And then what would be left for Q to do? Add 5. That's all Q has to do, is take the output and add 5 to it. The other way that could be is you could let P just do the squaring, and then Q would have to do the timesing by 5, or timesing by 8 and adding 5. Either one of those are correct answers. Number 5, we just practiced. So how do we start? Yep, we got a factor, see what happens. Okay, so let's see, I can take 4 out of that. Oh no, I can't take a 4 out, I can only take out a 2. Is that right?
Yeah.
Okay, and on the bottom, I can take out a 2x. There we go, that's better. All right, so I can cancel my 2's out. All right, so on the top, I've got let's double check that. So I factor that. The 2x out down here. Okay. All right, so what do I notice happens? I'm going to have a hole, and the hole is going to be where? Where x equals 4 is the point. So are these. All right, so where's that hole going to be? I'm left with 2x plus 1 over x. Is that what's left? So if I put 4 in, what do I get? 9/4. So we have a hole at 9/4. Okay, what else do we have?
2 is the,
What?
y equals 2 is the horizontal.
Y equals 2, and I can go back to the original problem, or I can actually look right here, it doesn't matter. Y equals 2 is my horizontal asymptote.
Would x equals 0 for the vertical?
X equals 0 would be the vertical asymptote, because if you look at your reduced problem, x cannot be 0. Now I need my intercepts. If I want the y-intercept, x will be 0. If I want the x-intercept, y will be 0. So if I plug in 0 for y, it doesn't matter what order I find these in. I do the x-intercept first. If I plug 0 in for y, now, Lily, it looks like we're going to get what? X equals -1/2. And what's my y-intercept? If I let, oh, wait a minute. Can I let x be 0? I don't have a y-intercept, do I? Why not? I have an asymptote there, right? So this one has no y-intercept. Again, you're not responsible for the graph, but if you were going to graph it, this is what it would look like. All right, I gotta erase all that. Anybody have a question about any of it before I erase it? All right, now I want the implicit functions. You're not being asked to sketch them, you're just being asked for what are they. So who remembers how we find the implicit functions? Get y by itself. Plain and simple. Get y by itself. Solve for y. So I will divide by 9. And then what? Take the square root of both sides. So y will equal the positive root x over 3 or negative root x over 3. These are my implicit functions. So if I needed, for some reason, to graph this equation, I would split it up into these two, put these two into my calculator, and they would both graph. Right? I'm not going to do the next one. You need to be able to do this. Draw the basic sketch of the 12 basic functions. So you need to be able to do that. Talk about their domain and talk about their boundedness. Now, we talked about, I put 3 of them up here a minute ago when we talked about their domain. We did not talk about their boundedness. What does it mean to be bounded? If a function is bounded, if you're going to say this function is bounded, what are you saying? It's contained. I love that word. It's completely contained. It has a ceiling and a floor. So think of one. Logistic function, perfect example. Not the only one. Sine and cosine are also bounded, right? They're completely contained. But you have also not just bounded, which is completely contained, but you have bounded below, which means you have a floor, and you have bounded above, which means you have a ceiling, right? So, can you think of a function that's bounded below? Absolute value, perfect example. Squaring function, absolute value. Now, or squaring function, yes, bounded below. Can you think of a function that is totally unbounded? Not bounded at all, top or bottom? Linear, cubing, logarithmic, right? There's lots of them. So you're responsible for knowing your curves well enough to answer those kinds of questions. Okay, now, we talked about this a minute ago, but this one has a little bit added twist to it. It's another absolute value, which means its shape is going to be a V. So the normal V looks like this. What have you done to this V? You moved it 1 unit to the left and turned it upside down. So I'm going to do this in stages. So you moved it 1 unit to the left and turned it upside down, right? And then what did you do to it? You moved it up 3. So would that be a picture of this situation? What's the domain? All real numbers. What's the range? Less than or equal to 3? Jamie?
When we were talking about the boundedness of the functions, what would the greatest integer one be?
It's not bounded. And Amy, I'm not going to memorize that. I'm going to look at the picture and say, whoa, there's no ceiling on this and there's no floor. Right? Yeah. You've got too much other stuff to memorize. We're not going to memorize that stuff. We're just going to look at our picture. Piecewise function. What shape have we got right here? What about the line? Intercept at, y-intercept at -1, slope of 1. So looks like this. Beautiful line, beautiful. But I don't want the whole line, do I? What part of it do I want? Where it's greater than 2. Here's where x is 2, right? Here's where x is 2. Here's where it's greater than, right? So I get rid of all this. Don't need it. What about that middle line? We just talked about it. Y equals 5 if x equals 2. 1x, 1y, 1 point. What's this? That's another line. What about this line? Intercept at 0 and a slope of -2. So down to right one. A little bit steeper line, just like that. What part of that line do I want?
X is also 2.
I want, here's where x is 2, right here, where x is 2. And I want the left side of that one. There you go. This point down here would be the point 2, -4. I put in 2, I get -4. So tell me about the domain and range of that function. The domain is all real numbers, and the range is
X is greater than
y is greater than or equal to, actually just greater than, y is greater than -4. Nowhere or equal to, that's an open dot. So it's just greater than. Regression, don't want you to forget about regression. You know what I'm talking about when I say regression? Stop, yeah, you got a table of stuff, information. You put it into your stat menu, edit, stat edit, list 1, list 2. And then you go back and ask the calculator to plot it using stat plot. And what's the purpose of the graph? One purpose only.
Well, you know if it's linear.
Let you know if it's linear or quadratic. It's going to be one or the other. There are other kinds of regressions, but right now we're just doing linear or quadratic. So then once you figure out from the graph if it's linear or quadratic, then you go back into the stat calc menu and ask it to linear regression, quadratic regression, whichever it is, and then it gives you the equation.
All regression is stat.
regression means taking a bunch of points and writing an equation that fits them. That's what regression means. You do it on your calculator through your stat features and your stat plot features. Okay, next, I can't really try to understand my own hieroglyphics here, but I think at x equals -1, is that an absolute minimum, absolute maximum, relative minimum? What is happening at -1? Where x is -1. It is an absolute minimum. And if you're an absolute minimum, then obviously you're also a local minimum, right? But that is an absolute minimum. What's happening where x equals 1? That's your absolute maximum. And what's happening where x equals 3? That's a relative minimum or a local minimum, right? Right? Okay. All right, let's see. Okay, that takes care of that. So you got some great review assignments in the book, 2 review sheets here in your packet. There's review 1 and review 2. I would suggest that you start on something in terms of review 1 and review 2 or the book review. Now, the test is only over the first half of the chapter. So when you do the book review, be sure you are doing only the problems I assigned, because we haven't covered the whole chapter yet. Tomorrow, when you walk in the door, I'm going to hand you a quiz, and anybody that whines is going to get punched, okay? That's on video.